Section 1.8, speed and velocity. When we're talking about objects in motion, we have to consider how an object moves, particularly how fast an object moves, how much distance that object can cover in a certain amount of time. What we call the speed of the object is determined by dividing just that. The speed of an object is given by the total distance that's traveled by that object divided by the total time that it takes for that trip. For example, if you travel 30 miles in an hour, your speed's 30 miles an hour. Travel the same distance in 2 hours, and your total speed is 15 miles per hour. If you did it in half an hour, your speed would be 60 miles per hour. Speed is another derived quantity. It's derived from length and time measurements. In America, speed is often measured in miles per hour, but generally in science we use kilometers per second or kilometers per second and meters per second. Remember again that length and time are both fundamental quantities. They're directly measuring fundamental piece of nature, the length of something, the amount of time that something happens. In standard units in science, length is measured in meters and time is measured in seconds. When we talk about speed, we have to consider two different situations. Think about when you're driving in the car. If you're driving in the car and you look at it down at your dashboard, you can tell how fast you're going. If you're going too fast and there's a speed trap, you can get a speeding ticket. You can get a speeding ticket if you were traveling at a particular speed at any instant while you're on the road. That speedometer on your car is measuring your instantaneous speed, how fast you're going at that point. When we talk about average speed, we're talking about how fast you go over the total trip that you travel. So your average speed across a particular trip. This is important because it relates to the total distance that you traveled divided by the total amount of time, as we discussed before. And often when we refer to trips to friends and things like that, we'll use the average speed, or we'll use the average speed to determine our average time. At any instant during a trip, you could be going 0 miles per hour, or 30 miles per hour, or 60 miles per hour, or 70 miles per hour. But your average speed for that trip might be 55 miles per hour. When we talk about velocity, velocity is a more specific measurement in physics. Velocity combines the idea of how fast something is moving, but also includes the direction that it's moving. When we measure quantities in physics that include direction, we refer to those quantities as vectors. Velocity is a vector quantity. Force is a vector quantity. Velocity is measured in a very similar way to speed, but it also includes the direction. If you want to know the speed of something, well, all you need to know is that that thing traveled at 60 miles per hour. If you want to know its velocity, you need to know a direction. So that thing traveled 60 miles per hour north. When we say that an object is traveling at a constant speed, we mean that the object is not speeding up or slowing down. The speed of the object is not changing. When we say that something's traveling at a constant velocity, not only is it not speeding up or slowing down, the object is also not changing direction. It's traveling in the same direction. So a constant velocity implies a constant direction. One interesting thing about velocity is the way that we perceive it. So, though you may feel like you're sitting at rest as you sit in your chair or in the classroom, you're actually not sitting at rest. The Earth is rotating. While it's rotating, it's revolving around the sun. The sun moves through the galaxy, but we don't perceive those speeds because everything around us is traveling at that same speed. Similar things happen when we drive on roads, especially roads like the interstate. If you're one of those people like me, I tend to drive at or about the speed limit, but not everyone does that. And when I'm driving, I'll get passed by people, and I know that they have to be going faster than me. It's the only way they can pass me. But they only appear to be going 5, 10, maybe 15 miles per hour faster than me. If I was at rest, if I wasn't moving, if I did not know that my car was going down the road, that person would not appear to be going that fast. If I were to slow down, he would appear to be going faster. His velocity is different relative to me because of the way that I perceive it. If I measure it from my car as I'm moving, I'll measure his car going 10 miles per hour. Were I to measure it from the side of the road, I would measure it going at 80 miles per hour. The measurement of his velocity is relative to how I'm measuring it. I always attempt to leave my students with this thought that I've heard before. If you were to be on a plane, or if you were to be knocked out and asleep and then placed on a plane in a room with no windows and no doors where you can't see in or out, the plane is traveling at a constant speed through the sky, turbulence or anything to imply that you might be on a plane. Right? You're just in a room with no windows or doors, and that's all you can see. How would you know you were on a plane?